Just because it fits the frame fits so it's on there.
Hello,
Okay.
guys.
Multiplicities and polynomial functions. Multiplicities of zeros of a polynomial function. The graphs of several polynomial functions of the form y equals x minus 2 to the n are shown below. We got x minus 2 to the 1, x minus 2 to the 2, x minus 2 to the 3, and the 4, and the 5, and the 6. Where? This is true. So, well, the x minus 2 to the 1 really didn't matter. But it certainly does matter for the other ones, right? Because they would all just be linear variations of x minus 2, x minus 4, x minus 8. Okay, right. So, yeah, if you see any of that stuff, because sometimes things don't transfer over to notebook all that well. All right, so what are we doing with this? We are showing them, okay? Yeah, so good, nice. Note that x minus 2 is a factor of each of the above functions, okay? What is the x-intercept of each of these functions? 2. Predict the x-intercept of y equals x plus 5 quantity squared. Negative 5. Use your calculator to verify your prediction. All right, so we got to get a calculator out. We got to get a calculator out.
Are you recording all this?
Yeah, actually, you know what? You get a calculator out. I'm just going to go to Desmos if I can. D-E-S-M-O.
Wow, that's been fun.
I'm not sure if the internet. Yeah, apparently it is. Okay. All right, what were we doing? X what? X plus 5 squared. And the x plus 5 was in brackets, right? Y equals bracket x plus 5 bracket squared. Caret 2. Look, negative 5. Our prediction has been validated, verified, and checked. Yes. There is a relationship between the exponent on the factor and the shape of the graph. Now you know this, right, because you did the other worksheet. Use this relationship to predict the following. If y equals, pardon me whilst I bracket these things. If y equals x minus 2 to the 7th was graphed, it would look similar to the graph of
X minus 5.
X minus what?
2 to the 5th.
X minus 2 to the 5th. Or
2 to the 3rd.
y equals x minus 2 cubed. If y equals x minus 2 to the 8th was graphed, it would look similar to the graph of?
6, 4, 2, 0.
What do you want to start with? 6, 4, or 2?
You wrote that wrong.
Oh, see? Because I had 6 on the mind.
1, 0.
Like so? Yes? No? Maybe? Yes? Okay. Good. You agree? For y equals x minus a to the n, describe the behavior of the graph at the x-intercept if the exponent n is even.
It looks sort of like a graph.
It will go up.
No, it's a bowl. It's an infinitely big bowl.
Infinitely big bowl.
Yes.
Okay.
That's good. It's like your wish bowl food.
Let's scroll on here.
It comes down to
lunch.
the X and then leaves.
Okay, so comes down. What do we say? Were we even here? Yeah. So
It comes down, touches the X, and then leaves.
comes down, touches the x in how many places?
1.
1.
All of the places in 1, 3 times.
Okay. So where were we? Describe the behavior of the graph of the x and exponent. It comes down. Touches the x. Intercept. And goes back up. Because what goes down, but that's not really true. But in this case, what goes down must come back up again. Fair enough? No, I don't actually have the big book of answers or the big book of correct answers, so we're just going to make this up as we go along. For y equals a x minus, or y equals x minus a to the quantity to the power n, describe the behavior of the graph of the x-intercept. The exponent n is odd but not 1. So odd but not 1, so not that one, so like this one or this one.
Comes from the left, and then goes up to the top right. Cubic.
Comes from the left, so you know what, let's quantify this a little better then. So instead of saying it comes down, so it comes from, let's get rid of down. Oh wait, the whole thing moved down. It comes from quadrant 2, quadrants. Touches the x-intercept and goes to quadrant 1. Yeah, whoops. No, that's fine. And goes to quadrant 1. So if we were describing its end behavior, we could say quadrant 2 to quadrant 1, right? Or we could say both ends open I.
Is it on quadrant 3?
Which really, if you're saying the same thing either way, but quadrant 3, there's no quadrant 3 if it's even. What do you mean even ones first? Right? Yeah, I know. We were fixing this. Right. So we just we clarified. We said instead it comes down and goes up, we said, hey, it starts here and it goes there. Okay, so where are we? So if it's odd, what does it do? Okay, so we are going to say it goes from quadrant 3 which is down to the left, crosses the x-axis, right? Goes across the x-axis. No, it's continuous. But what's the difference between odd and not 1 and odd and 1?
One is linear.
One is linear, so it just crosses through, right? It's straight line. This one, not straight line, right? It actually changes direction. So we're going to put a fancy name on that, right? Crosses the x-axis with a change in concavity. No, other than they rhyme. So if you are looking for a rhyme for gravity, concavity works. Okay. With a change in concavity and goes to which quadrant? Quadrant 1, right? So it goes from quadrant 3 to quadrant 1, crossing the x-axis with a change in concavity. So you're asking, what's concavity? Well, when you go to the dentist, you need a filling, they're going to fill cavity. So concavity, this curve here is what we call concave down, right? Because it kind of opens down, right? And if it kept going, then it would do this, like those guys, okay? But it doesn't. It goes from concave down, and it goes to concave up. So that's what we mean by a change in concavity, right? A change in the direction of the curve. So it's changing direction. If you're driving along this curve in a car, then you have to give some steering input, right? Because you cross the x-axis. You need to, I'm going to steer right, I'm crossing it, and I got to steer back to the left. You don't have to provide any, this is driving through Saskatchewan, right? So hold it straight and try and stay awake. Well, if you did, you probably wouldn't hit anything for a while. Describe the behavior of the graph at the x-intercept for y equals x minus a to the 1.
It's a line.
There. So it goes from which quadrant?
Quadrant 3 to 1.
Quadrant 3 to quadrant 1, crossing the x-axis. with no change in concavity. Then we'll change things. But you know what A does, it's just going to change the quadrants. A changes the end behavior, right? Yep. Okay. Okay, or, you know, straight line. It's a straight line. Okay, so it's power 1. The graph of a polynomial function is shown at right. Right? Sure. The x-intercepts or the graph are x equals? -3 and x equals? 1. The corresponding factors of the function are x plus 3 and x minus 1. The shape of the graph at x equals -3 indicates an even exponent, right? The shape of the graph at x equals 1 indicates an, yeah, that's odd, an odd exponent. The graph of the function can be written as the equation by the equation. Now let's use the minimal values. What is the minimal power on the x plus 3, which is supposed to be in brackets? 2. And what is the minimal on the x minus 1? 3. Why not 1? 1 makes it go straight through, right? So it's going straight through. If it's a cut straight through, it's a 1. If it's a cut with a change in concavity, then it's at least 3. If square and blank represent the smallest, we did that, then enter those values in the appropriate space. Really, like the instructions follow the graph the resulting equation with a graphing calculator to verify this function does represent the graph, or we'll use decimals. You can use your graphing calculator because you'll have that on you when you write various exams, except for one of the parts of the IB where you don't get to use one. So what are we doing? X plus 3 squared and x minus 1. So let's just change that to a 3. X plus 3 squared. And what was the other one? X minus 1. Was that one cubed? Oh, I put 9. X minus 1 was cubed, right? So when I put in the 3, then we should, I know, because I'm going to reveal this, right? When I put in the 3, then as if by magic, a graph looking a lot like the one that we have in front of us will appear, does it? Okay, what's the scale on the graph that you have?
A lot smaller. -35.
So if I like zoomed in,
So if you zoom in, you can't see the bottom. If you see the bottom too.
well, and then probably this is more spread out this way, and I don't know how to do that. All right, close enough. Right. The reason now, because this goes to like -3, I could set a window maybe. What's the window? -4 to 2 and -35 to 15.
I got it.
How do you set a window on this?
I don't know.
Well, neither do I.
Settings.
Where?
The red check.
Oh, here, the tool. How about the tool? Window. Here we go. What do we want? -4? -4 to 2. And what was it? -35 to 15. And I don't want to equalize the scales, so we'll go back. -4 to 2. All right, there we go. Right, get rid of this. Okay, does that look like what you got? Close enough. Close enough. Don't waste our time. Where were we? It can be said that the function shown has 2 zeros, right? -3 and 1. X equals -3, which has a multiplicity of 2, and x equals 1, which has a multiplicity of 3. Okay? So it can be said. So that's what we say. That's the definition of multiplicity. Whoa, where did I go? Hang on, we went to... Okay, so ready? Next page, right? For each of the following functions, brackets.
Yeah, apparently.
I don't know. It's the conversion from word to... No, yes.
So the definition of multiplicity would be the power that you would have to raise.
It's the power of the intercepts, the power of the zeros, right? So you look at the zeros and you say, oh, this one touches and goes, right? I call it a touch and go. This one touches and goes. It makes a U shape for those of you, because I'm just explaining this, waving my hands and not doing anything in the video. So, you know, that's an even multiplicity, right? So at minimum is 2. Okay, and then odd multiplicities, straight cut through, 1, any shape, change concavity, minimum of 3. Okay, so yeah, we say this 0 occurs with a multiplicity of. Right. In other words, if you can write out as factors and you said it's x minus 3 with a multiplicity of 2, you go y equals, let's back up. So if we go down here, we would say, okay, this equation could be y equals x plus 3 times x plus 3 times x minus 1 times x minus 1 times x minus 1, right? But that's sort of captured here by saying the x plus 3 occurs twice, right? So, Grant.
FX.
Oh, right. FX. What channel's that? 2.
I don't know.
Any shows worth watching on FX?
Well, I don't watch it.
Or
Relative.
I watch American satellite TV.
FX Canada?
Where it's like 9,000 something.
No, there's some good shows I think on it, but for each of the following functions, determine the zeros and their respective multiplicities. Circle whether the multiplicity is even or odd. Determine the y-intercept. Without using a graphing calculator, sketch a possible graph for each function, labeling all intercepts. Okay, zeros. X equals what? 3 with a multiplicity of 2, which is x equals -1 with a multiplicity of. Are you looking at the same sheet here? Which is? Y-intercept is?
No idea.
Hey, dude. 18. How do you get the y-intercept? Make x equal to 0. You stick it in there. 0 minus 3 is -3. Squared is 9. 0 plus 1 is 1. Fifth is 1. Times 2. 18.
Times 1.
End behavior.
Equals 1. Cardinal weight.
Even or odd? The whole thing.
Odd.
Odd. Positive or negative? Leading coefficient. Positive. So where does it start?
Somewhere on the left.
Quadrant 3. Where does it go?
Quadrant plus.
Okay, quadrant 3 to quadrant 1. Oh, there's no answers on this thing. Okay, or you can say it starts down left, or left. The left end is down, the right end is up. Right? I like the quadrant 3 to quadrant 1, right? We just started doing that in 30-2. And that's kind of the first time I've described the end behavior using quadrants. But yeah, it's pretty explicit. But you could say the left end is down, the right end is up. Okay, whatever you like. All right, so we got to sketch this, right? So what do I need? I need a 0 at 3. I need a 0 at -1. I need an intercept at 18. So those are all the values I need. I need the x minus, I need to start down here. I need to come up through here, flattening out, right, with a changing concavity. And the higher the multiplicity, the flatter the curve gets as it approaches 0, right? But we know it's only going to cross at this one point. It's just going to flatten to the axis pretty quick. Because when you get really, really small values near this that you're raising to the 5th power, they get really, really small. Small numbers to 5th powers get smaller. Okay, and then what? Then we got to come here. We're going to touch and go on the 3, and then head up into quadrant 1 to infinity. Not beyond those, because you can't really go beyond infinity. Okay, so we're going to come up like this. We're going to really flatten out, crossing here. we're gonna go through there, do something of which I know not, and right, arrows. Yeah, what happens if there's no arrows? Yeah, well, usually a half.
Zero.
And today is Wednesday, and arrow does err on Wednesday, so we should err on the side of caution and not.
I thought Arrow was on Friday.
No, it's on Wednesday. That's okay. You're not wasting your time watching TV then. That's a good thing.
I am.
Okay, we could graph this, right? And see what it looked like. I don't know there's a maximum there. I have no idea, right? I do know there's a local minimum here. I do know there's somewhere it has to turn, right? It's got to go out. So, maybe it does it at the 18. It could, just go to the 18 and then turn there. I don't think so, though. I think it just goes through it. Okay? But, I care not. G of x. Okay, look like that?
Yes.
Right. 0 is x with first 0. 1/2. Multiplicity? Even or odd? I'm not even going to dignify the rest by asking you, right? Is this an even or an odd number? X plus 3 squared. -3 with multiplicity of? Which is? All right. 4. Multiplicity of? Y-intercept.
566.
Really?
Yeah. Yes. It's 4 cubed.
Oh, yeah, 64 times 9
Negative because it's a negative 1.
times -1.
What's negative 4 times 3?
So 576.
Sorry, what? You just said it was negative. Oh, wait. But there's 4 negatives.
Yeah.
Ah, so you're positive?
Yes.
All right.
I know.
Well, this one's negative. You're going to get -64 times +9, which is 64 less than 640, right? Which is 576 apparently. And then we're going to multiply by -1, so we have a negative times a negative because it's positive 576. End behavior. So what's the whole thing? Is the whole thing odd or even? Even. So what's the end behavior?
Quadrant 2 and quadrant 1.
Yeah, quadrant 2 to quadrant 1, right? Okay, so we need a 0 at 1/2. 1/2. We need one at -3. We need one at +4. Leading coefficient is positive, right? We just quadrant 2 to 1. We got a y-intercept of 576. And it goes quadrant 2 to quadrant 1. So it's going to come down. It's going to hit the -3 with an even multiplicity. So what's it going to do there?
Because it's an even.
Touch it.
Touch and go. Probably coming up here, then turning. And what's it going to do here?
Drops straight down.
That was hardly not to scale.
Yeah.
What is that?
And then
It's angry birds.
that was an incoming text. But my watch will buzz and show me the message. Which, if only I could read it, because I don't have my reading glasses and it's like really small.
Can we read it?
Oh, I'll read it.
I'll read it for you.
All right, read it to me.
I'm blind.
I could read it. I'm nearsighted.
It says that your bill is ready. It's
Oh, really? Oh, okay, I know what that is. It's like I'm on a payment plan with visas. So why do you say, hey, you pay your bill, right? Like it's going to be paid.
It's going to be automatic.
You say how much it was for?
19.
But this graph is
It's like 108 plus change. I pay for my kid's phone too. Okay, we good? Yeah.
Yes, I am blind. Thank you very much.
Looks like that. All right, you do this one.
There might be a problem.
Right? I'm sure you're capable. Well, then again, I've seen your marks. And but I'm sure you won't let that happen again. Let's get my kid. You want me to get my kid to come in and talk to you?
Yes.
No. She did full IB.
She's already in Japan.
She did full IB here. She graduated in 2009. So she can tell you what, what's what. She'll give you, answer any questions. You guys are registering soon, right?
She's gonna make fun of us.
No, it's a trap and then make us quit.
Only make fun of you if you're not full IB.
I don't want
Well, then you'll get me. Okay, so there's all the information as if by magic appearing because I paused it and I wrote it in there. Okay, so we got one at 0. We got a y-intercept there as well. Kind of obviously, I suppose, because kind of has to be. Negative 2/3 and 15/4. MBA average quadrant 2 to quadrant 1. The negative 2/3 is multiplicity 2, so it's going to do this. This is multiplicity 1, so it's just going to cross through, straight through. And then this is odd. Alright. This is a little sharp, but a little sharper than it should be.
Oh my god, so good.
So is that what you got? Neat, huh? I mean, yeah, you figure all this out, right? Just from a couple of investigations and.
Negative 0.
Negative 0.
Negative 0.
1.
Okay, what do we got? 0,
0, 1.
2, negative 2,
Where'd you get 1 from?
1, odd, 2, even, 2, even, y-intercept 0. Quadrant and behavior. 3 to 1. I think not.
What are you talking about? I don't
Why
want
did you pick 2 to 4?
2 to 4. Who thinks 3 to 1? Who thinks 2 to 4?
You're an idiot. I have the only vote. I wouldn't do it.
Therefore, by virtue of. Why is it 2 to 4? Why is it 2 to 4? Okay. It's odd, right? It's of odd degree, so the odd degree goes 3 to 1 or 2 to 4, and it has a leading coefficient, which is negative, therefore it goes 2 to 4, right? Okay? So a positive leading coefficient does this. A negative leading coefficient does this.
I win.
That is very nicely.
That is a very nice drawing.
And my eraser does this. Take that. Okay, what do we got? 0,
Okay, it's recorded.
2, negative 2, 0. We're going 2 to 4, so I'm going to start here. And what's this one? So I'm going to start here, do this. Come straight through there. And do that. Okay? 2 thumbs up? No thumbs up? Yes? No?
My
Maybe
drawing
so.
skills are amazing.
Yeah. Next. I don't know why I did all these for you. How many pages are left?
Quite a bit.
Oh, it's like 2. Yeah. Please, let us work. Well, you got exercises. You can do those by yourself. Okay, multiplying the equation of a polynomial function by a constant. Use your graphing calculator to sketch the graph. Oh, no, decimals comes in real handy here. F of x where a equals a half, 1, 2, 4, a half, a quarter. All on the same grid. Copy the graphs below, label each with its equation. Alright, so all I'm going to do is what? X plus 3, x plus 1, x minus 2. X plus 3.
X minus 1.
X minus 1.
X plus 1, sorry.
Oh, x plus 1. Okay, fine.
X minus 2.
X plus 1 and x minus 2.
Fix the windows later.
Okay, yeah, so let's just go. Oh, wait, zoom in more. You're really close. Go home. Hey, homeworks. Okay. Homeworks. Ha! So you get to do later. I just. Yeah. Okay. You know what? I'm gonna zoom out a little bit, right? Okay. How's that? Pretty good, huh? Or should we change that? Let's change that. Let's leave the y is big. We'll go with small x, big y. Oh wait, that's the wrong one. How did I set it? Oh, tools. Window, so equalize, yes or no?
It is equalized.
Yeah, okay, I don't want it. So I don't want it equalized. Oh, I guess I gotta change it first. So y's, so x's, really, we don't need much, right? So what, negative 10 to 10?
5.
Negative 5 to 5? Sure, why not?
Negative 10 to 10. That's what the graphic calculator
All right,
is at.
negative 10 to 10. Okay, I'm gonna say don't equalize. What are you gonna go with for y's?
Negative 5 to 5.
What?
Negative 10 to 10.
No.
Yes.
50 is
All I need is
10.
This is pretty obvious.
What the?
You closed it. No, stop thinking. Use the red
How
color.
did you do this?
Yeah, I know. What's going on?
I don't know how you do it like magic.
Don't equalize.
I think it is.
Why did you press it?
What the?
Well, you can't copy paste on calculator.
Okay, don't click outside the window.
Don't do anything
Don't
else.
press the equalize. Don't press it. No.
But then it
Don't press
equalizes.
It will screw it up. This is too big.
There's a
Trust
reason
me
why it
for
says
once.
equalize.
That's whole line.
Don't press it.
Don't press equalize.
Yeah.
All right, there we go. Okay. Now what? We were actually doing something. Oh, so I want the same thing with what? 1. We got 1. So we need 2, 4, 2, 4, a half, and a quarter.
No, you label each equation.
Oh my.
Okay, so where were we? So I need the same thing. So I'm just gonna copy.
Paste it like 4 times. And just
That's-
Oh my god, you can't.
Oh.
What do I need? 4.
Ooh, halves.
Right. Forward.
Look at the line change color.
Okay, what did I want? 2, 1, a half, and a quarter? Or 2, 4?
Half quarter.
Okay, so I need a 2 here.
Yes.
2.
4.
Need a 4 here.
Half.
Should I go 1 half?
Yes.
0.5.
And 1 quarter. Well, it looks more impressive like this.
And cardio waves.
Okay, so let's move this out of the way. So this is showing you in color, right? And then each color is showing you what the graph looks like, right?
Right, to draw this.
Well, it asked you to sketch them, so.
Keyword being sketch.
Rainbow.
You could just say
Look so close to it.
refer to, okay, label each with its equation. All right, so that's more or less done. Repeat where a equals negative 1, negative 2, negative 4, negative a half, and negative a quarter.
So close to the graph.
Wait,
Yeah, look at that.
wait. Don't erase those and make another one.
It's so similar.
What?
I want all 10 of them burned. Don't erase the first 5.
Yo, Jacob.
Don't do
It's
it.
so close, right?
Don't.
Good job.
Yes.
What do I need? 5 more?
Yes. Yeah. And then don't confuse everybody.
3,
I think those have you right now, my problem.
Look at my
4,
graph. It's so good.
5.
No.
Oh, 5. Okay, what do I want? Negative 1?
Negative 2.
That's just confusing.
Negative 2?
Okay, I gotta make this better now.
Negative 4. Negative half. Of course.
Mine is too good.
Right has to draw this out. Negative a quarter.
Okay, that's about good.
And now make a cardio wave. I did that cardio wave.
Okay, there they all are. Although I really only wanted the negative ones on its own grid, right? So I can just go and erase the positive ones.
No,
Yes.
no,
Maybe-
it looks so
It's so
beautiful.
much prettier this way.
Can I-
Yes, 7.
maybe I can just turn them off. There. So there's the negative ones.
34 minutes in, guys.
Woohoo!
Yeah!
Yeah, 35 minutes.
I need a bigger hard drive in this thing. There's too many videos.
It's okay. It's
Uh,
okay. They have like 4 terabytes.
Okay. Now what? Was there some point? Summarize what you learned about the effects of multiplying the equation of a polynomial function by a constant. State
Makes it complicated.
what aspects of the graph changed and what remained the same.
Intercept counting and the
Times 2.
rate of change.
Well,
Change.
okay, what didn't change?
Nothing.
Or the
The x-intercepts did not change.
The y-intercepts change.
The y-intercept did change. Yes.
The degree of concavity changed.
The degree of concavity. What does that mean?
We have to like use tangent lines and find out.
It's moving, yeah.
Yeah. Stay in grade 11 for the time being. Grade 11 math. You're in grade 10. When you're in grade 11, you can do grade 12 math. So just hold off till this same semester next year. Okay? I don't think the degree of the concavity means anything, so you know.
There's a formula.
Yeah.
There's a formula.
Well, he wins.
Well, the degree of the equation is the same. All of these are of the same degree. The end behavior changes when you change the constant.
Yep.
The x-intercepts do not change.
Yep.
The y-intercept does change.
The biggest hill has the biggest variable.
The vertical stretch of the graph changes. Right? So how, yeah, like our minimums and maximums get bigger or smaller based upon the leading coefficient, right? Okay. So, 4 times that is bigger than 1/4 of that.
Can you make a rainbow? Just be like.
It's so much easier.
Right, then you don't have to talk to your grandma.
It looks like 2 eyeballs.
It's like
I like how one thing
I think it's watching me.
so close to it. Look at this.
Okay, so what are we summarizing? X-intercepts do not change.
I know I saw.
It's not fair. It's not great.
Apparently, if you use it once, you can only like
Use it like every day.
no. Usually
Okay, y-intercepts do change.
Yeah. You can use it. That's why you can't see one for it.
Just dunk everyone before the cooldown.
No, I thought it only like it only goes like 15 seconds if you still cool the eye.
It's scary.
You can use it within 15 seconds. Yeah. But then if you don't kill them, then it's gonna go cool down. Yeah, I know.
Yo.
What? I'm a Rhaegar. Oh yeah. This is how you're supposed to do it.
You can't stay away from the If you could, you'd have like
Okay, there you go. So
What?
x-intercepts do not change, y-intercepts do change. Multiplying by a causes a vertical stretch by a factor of the absolute value of a. And if a is less than 0, there is a reflection in the x-axis.
Yo. Was that written off the sheet that you just copied off of?
Pretty much.
Okay.
Well, you want me to get it right or not?
I think mine's wrong. No. That way you can mark this wrong on the test.
No, I can mark you wrong on the test.
On purpose.
Yeah.
You always do that. You're like, what? This one is wrong. No bad one. This is wrong.
Multiplying vertical what?
A, the letter A,
Fact.
causes a vertical stretch, different use of the letter A. By a factor of the absolute value of A, goes back to the first use of A. If it, no, we never say if it, because that makes no sense.
Less than 0. Then you lose. If it's less than 0, then you get a 0 on your.
If it is divisible by 5, what the heck is it?
Well, it's the letter I and T.
Yeah.
If a two-digit integer, oh, okay, now I know what it is.
I have a question.
Then it makes perfect sense.
I have a question though. What if we use the letters I and T as variables? And we roll.
Determine the equations of each of the following graphs as the multiplicities are of lowest values.
Wait, can you go back a minute?
No.
So watch the video and hear my voice.
Okay, so what we're going to do is we look at these, right? We can state the facts. So we're going to write this as,
Wait, these are actually not.
yeah, I know, y equals a. What's an intercept? Huh? Negative a half. So what's the factor that goes with negative a half? 2x plus 1, right? How many times does that occur? Multiplicity of? The negative a half.
Oh. I was looking at Y.
Yeah, just one, right?
Yeah, okay.
Okay, what else?
Oh.
Okay, so what do we know? We know this is even. If even are of lowest, whatever, multiplicity, then it's 2. Odd, 2 packages, right? 2 forms. If it cut straight through, it's 1. If there's a changing concavity, minimum is 3. Okay, how do we solve this? How do we know what A is?
We have to use the y-intercept.
Use the y-intercept, right? So you put in a point on the graph. In order to solve for A, you put in a known x and y, right? So you go, negative 3 is equal to A, 2x, well, 2 times 0.
Plus 0.
You know, solve for A. And then state your equation down here, right?
I believe that.
Using the value of A that you now have figured out.
I believe that is 1.
And that